So the problem talks about basically two blocks. Block 1 is moving forward at a speed of 11 meters a second, and it's smaller than block 2. And it essentially collides with block 2, and they stick together. Um, and this kind of sort of two-block system moves at the same speed. Um, and this problem basically deals with two big concepts. One of the concepts is inelastic collisions, where basically kinetic energy is not conserved and the two things collide and kind of stick together. This would be really common in like a clay ball problem. And the other thing that this problem deals with is the law of the conservation of momentum. Basically, within every collision, momentum is conserved, momentum as in mass times velocity. So the three questions basically ask different things. So it asks first, find the magnitude of the initial momentum of the two-block system. And then the second question asks to find the final velocity of this two-block system. And then finally, the last question asks, what is the change in kinetic energy? And we know that kinetic energy is not conserved in this sort of inelastic collision. So a strategy that we want to use to solve this type of problem is to equal the final and initial momentums to each other, because we know that momentum is always conserved. And we also want to subtract the initial and final kinetic energies to find the change in kinetic energy. So right here, we can find the initial momentum by multiplying m1 times v1, which is 6.7 kilograms, times 11 meters a second. So we get 63.7 kilogram meters a second. And then for part B, we want to find the final velocity. So to do that, we can do a little bit of algebraic manipulation here, because we know m1 v1 is equal to m1 vf plus m2 vf, because we know that this two-block system moves at the same velocity, and basically this is the unit for momentum, which is conserved. We can factor out vf because we know it to be equal to the other vf, since it's the two-block system is moving at the same velocity. And then doing a little bit of algebraic manipulation, we can take m1 plus m2 and divide it on both sides to get m1 over m1 times v1 over m1 plus m2 equals vf. And now that we have the variables all sorted out, we can just plug in numbers. And then this is basically 6.7, which is the initial, which is the mass, and the initial speed of 11 over 39, which is the mass, plus the initial speed of 6.7. And this ends up to be 1.61 meters a second. So what we can do with this is we can find the change in kinetic energy. So we can take the final kinetic energy minus the initial kinetic energy to get the change in kinetic energy. So basically, we would plug in 1/2 m1 plus m2 vf squared, because we know kinetic energy is equal to 1/2 mv squared. And basically, at the end, when the two blocks are stuck together, they basically act like one mass. And we can take the speed that we got before for this one. And then we subtract it by the initial kinetic energy, which is just like the small block going forwards. Doing all this math out, we get the value of minus 346 joules. All right, so one of the mistakes that someone could make in a problem such as this is that they don't understand the difference between inelastic and elastic collisions. In this specific example, you have to understand that the two blocks stick together and basically kind of become one mass moving at a certain speed. That's pretty crucial to understanding this sort of problem and understanding that there is a difference in kinetic energy from the start and the end of the problem. Thank you.